Hi, my name is Toni Perämäki. I'm CEO at Valohai. And next, I'm going to run through a quick Valohai demo so you get a high-level understanding on how the platform works and what are the core functionalities of the platform. First of all, Valohai is built around these three core concepts. First being the knowledge repository. So whatever you do on the platform, Valohai automatically tracks, logs, and versions all of that for you. This means that collaboration, whether it be around models, experiments, or different metadata, visualizing those can be done easily. It also means that reproducibility is basically given. If you run something on Valohai, you can always reproduce it later on. Second concept is smart orchestration. What that means is Valohai automatically handles the whole orchestration layer for you, whether it be on your private cloud environments or on-prem. So Valohai supports all the major cloud players, AWS, GCP, Azure, on-prem, and we can also easily run the platform on a multi-cloud or a hybrid environment. So we can really make sure that you don't need to focus your time on orchestration and putting your engineering resources into that. Third, being the developer core. What that means basically is that Valohai is fully agnostic when it comes to frameworks and languages that you can use. So, any machine learning framework, any programming language. And this also means that in addition to machine learning workloads, you can run data, ETL pipelines, and workloads on the platform. So essentially, you can run any code with Valohai. Then if you look into tooling, so there also we try to keep everything as agnostic as possible. This means that you can work with Valohai IDE, any IDE from PyCharm, VS Code, Spyder, R Labs, you name it. So you can keep on working with the tools you love. If you're working with notebooks, Valohai gives you a possibility to work either with local notebooks that are connected to Valohai implementation or with hosted notebooks. Then we also have a Valohai graphical user interface that can do everything that the platform can do. And of course, the whole platform is built on top of API. So this means that integration to CI/CD or application layer happens super easy. Then let's jump into the actual demo. So what I have here is a Jupyter Notebook running on my local machine. On another window, I have a Valohai graphical user interface with an empty project called Valohai Demo. And then I have a terminal window. So as said, you can work with any of these ways, but let's say you're working with your favorite IDE, Spyder, PyCharm, so forth. You can just write the code, and then after you're done, you save, jump to terminal, and instead of, let's say, writing Python run, you basically write Valohai exec run train. W means watch. I want to see what's happening while the run is going on. And ad hoc means that instead of the default, which is pull my code from Git, so GitLab, GitHub, Bitbucket, and so forth. Instead of that, take my local code from my working directory, package it up, send it to Valohai implementation, and run it. When I run it, Valohai starts doing just that. So we spin up the cloud instance, in this case, Azure instance, pull in the data that's required for the execution, pull in the container, so you can use any Docker container you want, and the code, and start running everything. While the execution is going on, you can visualize different metadata metrics in real time. I'll show you that in a second. And when the execution is done, Valohai automatically, first of all, saves all the output data, versioning information, logs, metadata, saves those back to your data store, and after that terminates the instance that you were running. So from a user's perspective, machine orchestration is fully automatic. Data transfer back and forth from the data store is automatic. Tracking, login, versioning is also automatic. So this really lets you focus on the data science work that you're doing and the core of your work. If you're working on notebooks, so in this case here, a local notebook, we have a Jupyter Notebook extension that connects your local notebook to Valohai implementation. So you log in with your own credentials or your organization credentials. So Valohai supports SSO. Select a project that you want to tie your code into. So if you look into Valohai from an organization management perspective, Valohai basically have organizations, teams, and projects. And you can invite different people into those three different levels, but also data and computation access happens on those levels. So you can always make sure that only the right people have access to the right data and environments and so forth. So first, we select the project we want to tie this code into. Then I have a selection of different environment types that are available for me from our admin. So here we have our shared AWS, GCP, and Azure instances. But in your case, of course, you would have your private cloud or on-prem instances. So Valohai is always implemented into customers' private environments. So you can always be sure that data stays within your environment. Orchestration always happens in your environment. We don't transfer them outside of your network. When those are selected, we are ready to roll. So now instead of running locally here on my own machine, I can, with a click of a button, start a remote execution that takes this local code, pushes it into Valohai, and runs it there. And as we're running remotely, I can just continue working on the code instead of waiting for the execution to run or end. And then I can start a secondary execution in parallel. And maybe I want to try with the third version of the code. Also now I'm just changing the learning rate and epoch, but essentially a different code version. And start that. And Valohai handles all the orchestration just as we did on the terminal side earlier on, fully automatically for you. And then if we jump into the graphical user interface, here you can see everything that is happening within the project by any of the members who are invited into this project. So in this case, we have only my VH demo account running executions. So the first one, the one that we run from the terminal, is already completed. We have some metrics that we collected and some parameters. You can see the parameters that were used. The three notebook runs are still in queue because we didn't have that specific type VMs ready. So Valohai is spinning up the environments as we speak. And whenever the environment is available, those executions are pulled from the queue and run. But while we wait for that, let's look into the number one execution that we already did. And let's name it our first run. Yeah. So let's look into that. So here's the versioning information. So as said, this happens fully automatically, making everything reproducible. So you know that which was the environment used, code version, Docker container, command, input file, or files or data set, parameters, who did this when, how long did it last, and if you add your cloud cost in from the admin side, you can also tell what is the cost of this execution. So really starts to give you visibility on what actually does it cost, for example, to train a specific model or pipeline. Logs are of course saved, and as you can see here, we're printing accuracy and loss every epoch into standard out. Why we do this is that this is the way Valohai follows your metadata in real time. If we jump into the metadata layer, here we can see that information accumulated in real time. So in this case, the accuracy and loss. So here you can follow everything that is happening within your execution in real time, so you can see how your models are converging. And if you see that, okay, this is not going anywhere, I can just stop this, copy it as a new one, change some details, and rerun it. So making it also super efficient to run things. On the output layer, we have the versioned output data. So in this case, a TensorFlow H5 model file. Let's give it a tag as we go. So let's tag it for production, so we can later on pull it for our deployment endpoint. Then on the nodes layer, we can tag team members, leave notes, I'm the only one in this project currently, so I can only tag myself, which is kind of sad, but that's my life today in this demo. So the person you tag gets notified. And then we can also do different type of alerting, meaning that, anytime pipeline or execution is ready, something's wrong, get that information right away, not, at some point in the future. And not alerts and notifications work in-app, email, Slack, and over with webhooks, essentially anywhere like Teams or any other platforms. That's about kind of single executions. And now we can actually see that also the other executions are now spinning up. And instead of following a single one, we can of course compare executions in real time here on a single view. Of course, now we have only the first one here, but as soon as the other executions start to produce some metadata, we will see the graphs also populating here in the same view. Then let's look into pipelines. So up till this point, we've been basically looking into how to run a single execution, in this case, a training job or pre-processing or batch or so forth. But instead of running single works, you at one point or some point want to start building pipelines that can be then automated in different ways. So in Valohai, pipelines are basically essentially defined as a YAML file. So there's a simple YAML definition that defines the pipeline. If you're not fan of writing manual YAML files, there's also a couple of other options. So we have a Valohai Python utility library called Valohai Utils. So with that, you can automate the YAML building and pipeline definition, so you don't have to do that by hand. And then we also have a graphical user interface for building the pipelines drag and drop style. But instead of me now starting to build the pipeline and you watching me do that for the next 10 minutes, instead of that, let's pull a pipeline from a template. So here's an example pipeline, and let's kick it off and let it run while we speak. So now, like that. So here we have an example pipeline where we have a pre-processing step that pulls in data, does a data transformation, saves that data out, and passes it to 3 parallel trainings. So we train 3 different models. After that, each of them are evaluated. And the last step basically pulls in that evaluation information, picks up the best out of the 3, and deploys that to a Kubernetes endpoint as a REST endpoint. Here, of course, now I started this manually, but how our customers are actually using Valohai pipelines is that, simple API call from CI/CD or application layer triggers execution or pipeline. Every time you push a new code version to master or main branch in Git, that triggers with actions retraining with that code version. Or maybe you want to follow a specific data bucket, and whenever new data arrives, you trigger a Valohai pipeline that pulls in that data and retrains a model with that data. Or we can follow endpoint metrics from the production environment and then trigger with that. And last way, of course, well, many are using is scheduled run. So you can hear in Valohai build triggers. So let's say, we have a new data set coming 8 a.m. every Monday morning. So maybe 9 a.m. We want to run a specific pipeline every week to pull in that new data and do some actions on it. So you can easily do this type of pipeline scheduling. Couple of things on the pipeline. So here, of course, we have some nice looking boxes, but a couple of things to note. So first of all, each of these different pipeline nodes can be run on a different computation type. So let's say we want to run the pre-processing on a high memory CPU and then the training on GPUs. So that's totally possible. And also pipelines are dynamic in nature. So that means that we can these are not static pipelines, but you can span out to different type of conditioning. If this happens, do that, and so forth. So makes also by working with pipelines super easy and convenient even in more complex use cases. And we see kind of on the pipeline side, the largest pipelines that our customers today are running consist of more than 500,000 nodes in a single pipeline. So scale is definitely not an issue with Valohai pipelines. As a last thing, let's look into deployment. So Valohai has basically multiple ways of possibilities on deploying models. First being, of course, batch. So running a batch in Valohai is just creating an execution either on the GUI, CLI from the API, or any of the ways that you can work with the Valohai. And instead of running model training task, we run a batch inference task. So here we basically have a selected an environment, container, command, and then we give some images for the batch. Only thing that is missing is the model file. So let's pick that up. And when you do execution with Valohai, we automatically build a data catalog out of all of the artifacts that you produce. And this is fully searchable, so with file name, execution number, or in this case, the tag that we gave earlier on to the model, one of the models, we can find the right one. And then running the batch is just running that execution. So Valohai spins up the environments, pulls in the model and the data, runs it against the model. Here we can see some outputs, and then those results are saved back to your data store and the execution is killed. So that's how a batch works. And if you go into real-time deployments, that's under the deployments tab. So here we have the endpoint that we generated 3 minutes ago from the pipelines. So deploy that model, but let's start another model on the side. Let's create a version. And how Valohai real-time deployment works is that the inference code, whatever you want to use, comes directly from a Git repo, and it can be any code you want to run on the endpoint. Then there's a small YAML definition for the endpoint, where we set a couple of things, kind of Docker container, what is the code that we actually want to run on the endpoint. And here again, we're looking for the model that we're looking to deploy. So let's take the same one that we used in the batch. So we pick that up. Then there's some options to select if you need to specify something in more detail. And of course, here we're picking up the model manually, but then when you're working, for example, in production pipelines and workflows, when you have a model that is ready for deployment, you would give it an alias, let's say production latest, and then here in the deployment definition, you would, for example, define that, pull in whatever is the model under the alias production latest tag. So you don't have to manually do these things when you're doing the more automated ways of doing. So we have the model selected. We don't need to put any additional information, and then we just create the endpoint. And what happens next is Valohai takes the model, pulls in the code from Git, wraps around the model, Dockerizes that with the container of your choosing, then pushes that Docker image to your container registry, and then from the container registry, we deploy it on your Kubernetes cluster. So you, as a data scientist or whoever working with the platform, without understanding deeply Kubernetes or needing to work on the different Kubernetes technologies, you can easily deploy to Kubernetes. Valohai handles the deployment for you. On the cluster side, so cluster management still resides with you as a customer. So basically your DevOps engineering team needs to set up the cluster, define scaling rules and such, but then Valohai automatically deploys on that cluster, scales automatically with those cluster scaling rules that you have set and so forth. In deployment, we can of course follow, logs, cluster status, see some metadata on, printing some metrics. Currently, we don't have anything coming up, so there's no metrics available. And with different integrations, you can do drift detection and more complex, let's say, bias detection on your models in production. So that was quickly on real-time deployments. And of course, there's also a possibility to deploy it on edge, but edge is always a little bit of a wild west. So there's no one way of deploying to edge. So that differs over our different customers. And usually the edge deployment is then worked together with the customer to see like what is the best option for you. That's a quick demo on Valohai. I want to highlight still one thing before closing. So then, of course, on the admin side, you can manage different things. So as you have different teams, different, organizations, team members. So you can manage all of these here, see usage, how much a specific project is using computation, how much a specific user is using computation. So really can start to get an understanding how are different people working, how is cost accumulated, and so forth. So making also the management of the data science projects super easy. This is everything this time. Hopefully you enjoyed and liked what you saw. And if you have any questions, feel free to reach out to us, and we are more than happy to answer those and help you with Valohai. Thank you very much.